So thank you. So this morning we are going to have a great event since on behalf of the International Astronautical Federation, it is my great pleasure to welcome you so numerous this morning. And we are going to organize the IAF Excellence in Industry Award ceremony. And in order to give you an overview of this exceptional award, please allow me to introduce on stage the incoming IAF President, Professor Pascal Ehrenfreund, and the IAF Vice President for Industry Relations, Bruce Chesley. So Pascal, Bruce.
Thank you, Jean-Yves, for that introduction. Good morning, everyone, and welcome to Industry Day, where we feature the many ways that industry makes all these space visions a reality. You'll hear a lot more about the plan for Industry Day in a little bit, but as the first order of business here on Industry Day, we want to get right to the awards ceremony. So to that end, it is my pleasure to briefly introduce the latest addition to the IAF stable of awards, the IAF Excellence in Industry Award. It was launched by an initiative of the IAF Industry Relations Committee, and this brand new award is intended to distinguish an industry organization, a member or non-member of the IAF, for introducing innovative space technologies to the global marketplace and being recognized throughout the space industry for successfully executing a landmark space mission. This year, this prestigious award is being awarded to Blue Origin, an IAF member since 2016, for distinguishing itself as a true leader in developing reusable launch systems and liquid rocket engines, having achieved history-making vertical takeoff, vertical landing flights with their new Shepard suborbital launch system. As a commercial space company, Blue Origin has collaborated and cooperated with universities and space agencies, conducting microgravity research on several suborbital flights to space, demonstrating excellence in mission planning and execution. And now, it is my honor to welcome on the stage to receive this award the founder of Blue Origin, Jeff Bezos.
Excited about it. Thank you.
Good morning to everybody, and it's wonderful to have you here, Jeff, and you are the first recipient of this Excellence in Industry Award. So how do you feel?
Well, I'm just hoping it'll go up from here. Hopefully the next recipients will be more deserving, but thank you. I'm actually incredibly honored and appreciate it very much. Thank you.
Yeah, good. So I think many of the participants here, and we have a lot of young participants, young professionals, students here in the audience, they would like to know how you actually founded Blue Origin. What was the moment before the spark? And I think also everybody knew that already in high school you gave speeches about space.
Yeah, since high school I've been trying to turn Earth into a national park because I think you know, one thing that's very clear, and we know this without any doubt, there's one good planet in this solar system, and it's Earth. We've sent robotic probes to all of the planets. This is the good one. And it's not close, by the way. So we need to preserve it, and now humanity is becoming so large compared to the size of the planet that we're really entering an era where we're affecting the planet. And we want to have a civilization of growth and dynamism, which means we need to be able to expand out into the solar system. There are so many resources there that we can continue to do interesting things and continue to use large amounts of energy and so on. It's just we probably can't do that on this planet. So my long-term prediction, and this is going to take hundreds of years, so don't worry prematurely, Earth will end up being zoned residential and light industry. And all the heavy industry will be done in space. But that's going to be a project for future generations. And you know, I was inspired by the Apollo program. I was a 5-year-old boy when Apollo 11 touched down on the surface of the moon, and it had a big impact on me. And you know, I've been thinking about and studying and working on understanding rockets and propulsion and space vehicles ever since then. And once you get interested in something, it's a flywheel. You just learn more and more. And this is the kind of thing that cannot be done by a single company. These kinds of initiatives, what we really want to do, the things we really want to do in space, have to be done by industries. And in fact, they have to have entrepreneurial dynamism. I have witnessed that on the internet over the last 2 decades, and it has been incredible, the amount of entrepreneurial dynamism on the internet. On the internet, you can have a kid in his dorm room start a company that today, with no resources, start a company that today is worth $500 billion. That's Facebook and Mark Zuckerberg. You cannot start an important space company in your dorm room today. It's impossible. And the reason it's impossible is because the price of admission is too high. We need more of the infrastructure to already be deployed to lower the price of admission, the heavy lifting infrastructure. When I started Amazon 25 years ago, I did not have to build a transportation network to deliver the packages. It already existed. It was called the post office, the Royal Mail, Deutsche Post, and so on, all around the world. We could stand on top of that infrastructure that had been built at CapEx costs of hundreds of billions of dollars over many decades. Today, it's similar. I mean, you can go on and on, but you know, we didn't have to develop a payment system for Amazon. It already existed. It was called the credit card, and so on and so on. When entrepreneurs have to do heavy lifting capital deployment, the whole entrepreneurial dynamism cycle stops, and you can't have 1,000 experiments bloom. And so that's the real mission for Blue Origin. We know how to lower the cost of access to space. We need reusability, real operational reusability. When you look at the costs, it has nothing to do with the propellant costs. The fuel and the oxidizer are incredibly inexpensive. What we need is to reuse the hardware over and over and over again, and it can't be fake reusability where you bring the vehicle back and inspect everything, x-ray everything, disassemble everything, and then put it all back together. That's not real reusability. You have to land, refuel, and fly again. That's an extremely challenging engineering problem because you know, it's so, our ability to get into Earth orbit is kind of right on the edge of what's possible, even when you do it in an expendable fashion. So when you add the extra mass and systems, landing gear, and so on required for reusability, you're making your engineering challenge even harder. But it's worth it, and it's possible, and that's what we need to achieve. So that's why I started Blue Origin. I think it's the most important work I'm doing if I look over the really long term. And I often think about Earth. It's so interesting that Earth is just the right level of difficulty that you can get into orbit with chemical propellants. If Earth were a little smaller, had less gravitational field, it'd be really an easy problem. And if it were much heavier, it would be an impossible problem. So we've kind of been given this perfect challenge as a species due to the mass of our planet. And so it's a really fun problem. And that's why it attracts so many brilliant engineers. It's one of those things that stays right on the edge for a really long time. And we need to move to that next step. And I guarantee you, when we have real operational, reusable vehicles and we dramatically lower the cost of access to space, then you will see it'll be the next generation. It won't be my generation. It'll be some of the people in this audience, though, because a lot of people in this audience are young. You guys will experience that entrepreneurial dynamism. And then there will be thousands of companies doing interesting things in space. Because once you get to space, it's almost unlimited what you can do. It's very interesting. The problem of getting to space is highly constrained. It's a very difficult engineering problem, but there aren't a lot of new ways to do it. But once you get into space, then creativity can really be unleashed. And that's going to be incredibly exciting. I want to live a really long time so I get to see that.
You have a vision, you execute it, and you are with your heart. That's 100%. Really something important.
Every important decision I've ever made has been made with my heart.
Great. Since this award is about the accomplishments with New Shepard, we would love to have an update on what's going on.
Well, I have a video. Maybe we could start that update with a video, if you would mind rolling the New Shepard video. Here's our West Texas launch site. I love watching the liftoffs, but really, I much prefer watching the landings. I think one day all rockets will have landing gear. This is liquid hydrogen propelled. It's the BE3 engine. It's liquid hydrogen, liquid oxygen. We've done now full envelope escape testing. This was a particularly impressive test. The propulsion module was not required in its design phase to survive an escape event. And we did a max Q escape test to test that corner of the envelope. And even though the 70,000-pound thrust escape motor blasted the propulsion module, it just kept flying and came back and landed. We thought there was a chance that would happen, but we weren't sure. You see the big puff of dust there. That's the retro thrust system that takes out the last few bits of velocity right before impact. Thank you. This is a very good opportunity for me to remind everyone in this audience that such things are done with gigantic, hardworking teams. And so I'm the one on stage, but back in Seattle and in West Texas and in Florida and in Alabama, there are over 2,000 Blue Origin employees, and they're the ones who are receiving this award, and they're the ones who make all of that work. It's truly incredible, and I'm so proud of them. This vehicle was designed from the beginning to help us with New Glenn, which is our orbital vehicle. So for a suborbital vehicle like this, there is absolutely no reason for the propellant, for the fuel to be liquid hydrogen. It's higher performing than is needed for this suborbital mission. But we chose liquid hydrogen because we knew that the BE3 engine would eventually be in an upper stage variant, in a vacuum variant, would be with an extended nozzle and so on, would be the engine for our upper stage. You really want liquid hydrogen for an upper stage on a orbital vehicle. You need that performance. And this is, especially if you're ultimately going to make the whole thing reusable. And so we started from the beginning because we want the BE-3 engine, to be the most used, most flown rocket engine in the world. And that's what the tourism mission allows. And so the tourism mission is a mission that can be flown over and over and over again. And if there's one thing that is weirdly consistent about us human beings, is that we get better at everything we practice, in every field of endeavor. They say that if you're going to have a surgery, make sure your surgeon does that operation at least 5 times a week. And it's just true that we get good at things that we practice. So we want to practice with liquid hydrogen. We want to practice with the BE-3 engine. We want to practice with all the valves and other things that go along with that engine. And then that becomes the engine in the second stage of New Glenn. So in the end, we get to learn all the things that we're doing here. The reason we chose vertical landing, at this scale, there are a bunch of different landing architectures that work really well. But the thing I love about the vertical landing architecture is that it scales extremely well. In fact, the larger the vehicle, the easier the landing, because it's the inverted pendulum problem. And it's, you can imagine it's pretty easy to balance a broomstick on the tip of your finger, but try doing that with a pencil. It's very challenging to do it with a pencil. It just doesn't have enough moment of inertia. And so as the vehicle scales, vertical landing gets easier and easier. And some of the other things that you would look at, they're possible, but they get very challenging. Really big wings get very challenging. Parachutes tend to scale very poorly at very large size. So you really end up wanting vertical landing, I think, if your vision is to one day be building very large vehicles.
So the New Glenn will fly in 2021?
New Glenn will fly in 2021, and I have a video there too. Oh, I can show. This is a video we've never shown before. It's a video of the New Glenn fairing tooling. And New Glenn has a gigantic fairing. It's 7 meters in diameter. The volume of the New Glenn fairing is twice the volume of anything on the market today. And we want to show that video of the New Glenn fairing. We can kick off that conversation that way. Okay. It's a really cool video. This is our factory where we're building New Glenn in Florida. We're building it right there at Cape Canaveral so that we don't have to transport the vehicle very far. That is the fairing moving around. There's a cool little robot underneath it that moves it around. It's being transported into the oven to cure the composites. There's the little robot we don't want that in the oven. That doesn't need to be cooked. And so anyway, there's the fairing. And I show you that just so you get some sense of the scale of New Glenn. New Glenn is 3.85 million pounds of liftoff thrust. The first stage is liquefied natural gas and liquid oxygen as propellants. It uses 7 of the BE-4 engines, which are Oxford stage combustion engines. Each of them is 550,000 pounds. It's a very large vehicle and highly capable for both big LEO missions and also for GTO missions, GEO missions, and also for lunar transfer missions. So super excited about flying New Glenn in 2021. Everything we learned, and by the way, the lessons that we have learned building and flying and operating New Shepard are incredible. So much learning, and to have learned all of that, and now everything is better when you do version 2, everything. And New Glenn is version 2. It just happens to be at dramatically larger scale.
In May, you announced Blue Moon.
Yes.
And we have a really incredible model here in the middle of our exhibition here at the IAC. And what have you done since then on the lunar lander and also the BE-7 engine? Yeah,
well, I have a fun video to show of the BE-7 engine. This is the lunar descent engine. It's liquid hydrogen, liquid oxygen, 10,000 pounds of thrust. highly throttleable, which is of course required for a lunar landing mission. You burn off so much propellant, you have to be able to throttle down. Here it is. This is an infrared camera view of a test of the lunar landing engine, the BE-7. We now have 13 minutes of test time on the BE-7 engine, including the longest continuous duration fire of 3 minutes. And we won't make you watch all 3 minutes here, but but this is this is going to be to use. You really want your highest performing propellants to be at the end of the mission. You're carrying all that weight the whole way, and so this is a hydrogen-powered descent engine. It'll also be used in the transfer element. I have another. I have an actual new news announcement that I would like to make.
Please go ahead.
Having to do with Blue Moon. I'm excited to announce that we have put together a national team to go back to the moon. And if you could put up that slide. Blue Origin is the prime contractor. Lockheed Martin is building the ascent stage. Northrop Grumman is building the transfer element. And Draper is doing the GNC. We could not ask for better partners. Blue Origin is going to, in addition to being the prime, is going to build the descent element. You think about these partners. I mean, Northrop Grumman built the original lander. They now deliver cargo to ISS. Lockheed Martin is, as far as I know, the only company that actually lands on the surface of Mars. They are unbelievably competent in space. They are experts in life support systems, so to have their expertise on the ascent element is a really big deal. And Draper is doing the guidance and control, an incredibly complex job for landing on the moon, especially when you want to do a precision landing. And of course, they did that for the original Apollo program way back then. But today, it will be done in a completely new way. And I recently had a chance to tour Draper and see their modern GNC methods. And today you use advanced techniques like computer vision to do precision landing using landmarks that exist on the moon. And it's going to be a spectacular way to do it. So anyway, this is a national team for a national priority. I could not be more excited to be doing it with these partners. And this is the kind of thing, it's so ambitious. It needs to be done with partners. This is the only way to get back to the moon fast. And this time we're going back to the moon, and we're not going back to the moon to visit, we're going back to the moon to stay.
That's also a very important announcement for this conference, and very exciting news. I know that you have to head out very soon to New York, so I have one last question.
Yes.
Yeah? I wanted to follow up on your speech in May. You announced the Club of the Future. Mm-hmm. And can you tell us a little bit more about that?
Yeah, the Club for the Future is a nonprofit that Blue Origin has founded, and it is designed to inspire K through 12 kids about space and about the future and to have visions for space. The first thing that we're doing is really fun. We're asking kids and teachers to send us postcards of where they draw on the postcard their vision for the future of space. And then we are in New Shepard taking those postcards up into space and then mailing them back to the kids. And we've already received a lot of postcards, and so we're going to be a lot of postcard cargo going up in New Shepard, which we're thrilled about. And some of the postcards are so touching and moving and brilliant, as you would expect from young kids and their ideas about space colonies and what the future in space might be. And it's just lovely to see. And because what we are talking about and what we want to achieve is a multi-generation endeavor. It's critical to continue to inspire young people to be interested in space and to be optimistic about the future, just as many of the people in this room who are my age or around there were inspired all those years ago by the Apollo program.
Wonderful. I think this was a very 20 fascinating minutes of new developments, of exciting news, and in particular, why this first award of, excellence in industry has been awarded to you. I think we want to thank you with the entire audience and with everybody. It was really a pleasure for having you here, and I think also everybody wants to congratulate you again for this award, and we hope you're coming back to the IAC soon.
For sure. Thank you, Pascal.
Okay, thank you. That's really, really nice, yeah.